Hi, Assalamualaikum warahmatullahi wabarakatuh. This video is the third part related to the idea of one sample sign test. And in this video, I'm just going to give one example related to how can this procedure be applied. So in a study of myocardial transit times, the appearance transit times in a series of subjects with angiographically normal right coronary arteries was measured, and the median appearance time for this study for this group was 3.5 seconds. Suppose another research team repeated the procedure on a sample of 11 patients and obtained the results as shown below. Could the second team concluded at the 0.05 significance level that the median appearance transit time in the population from which its sample was drawn is different from 3.5 seconds? So that's the overall question. And based on the information above, we are going to start off with formulating the null and alternative hypothesis. And we can get a glimpse of our alternative hypothesis based on this keyword given here. So different means unequal, and clearly this statement right here corresponds to alternative hypothesis statement. And since we know that this is the alternative statement, we can come up with a complementary null hypothesis statement. So that's our starting point. All right. The first part is to formulate the hypothesis. This is the population median M equals to 3.5 versus the alternative not equal to 3.5. And also let's note that the significance level alpha is 0.05 and our sample size is equal to 11. So that's it really. We have taken out all the informations from this part here. Okay, now in the second part, what we need to do is we need to obtain the test statistic, and here is our data set. What we need to do is we need to find the difference between this data set with the hypothesized value given here. So the difference can be found quite easily. So here is the difference between each of these value. And what we need to focus is we need to focus on the sign of the differences. So here the sign is negative, negative, positive, negative, 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 negative. Now, what happens to zero value of difference? When you have zero difference, you need to eliminate this out of your data set, and therefore the sample size over here has to be reduced accordingly. So instead of having sample size equals to 11, our sample size now becomes 10. So the test statistic, according to the explanation that I had given in the previous video, the test statistic is just the number of sign that appear less. Okay, so in this case, this is the sign that appear so much less than negative sign. So how many times it occurs? It occurs only one time. Therefore, the test statistic here is equal to 1. Alright, so that's the second part. Now, for the third part, we need to decide whether the null hypothesis can be rejected or not. So here is, we are going to deal with the process of finding the probability. So you have to refer to a binomial table, and this is the probability that you need to find. Here is our random variable k. What is the probability of k being less than or equal to small k? Small k here is actually the test statistic, in other words, okay? Given sample size is 10 and the probability is 0.5. So if you continue the step-by-step process, this will be k less than or equal to 1, given sample size 10, probability 0.5. And basically what it means that you are going to find what's the probability k is equal to 1, given 10, 0.5, plus probability k is equal to 0, given our sample size is 10 and 0.5. And well, if you have the table of binomial probability, you can go straight to n equals to 10, probability 0.5, and you can see for probability for k equals to 0, this is the probability. For k equals to 1, this is the probability, and you just add up these two probabilities together. So it becomes 0.0098 plus 0.001, and it is about 0.0108. So that's the third part, where you have to find this probability. Okay, so this probability. Now, if you don't want to use the binomial table, that's fine. You can, of course, calculate the process on your own. For example, for this one here, this probability here, you can just find using the binomial formula. You know how to find it. This will be 10, and then the probability is 0.5 and 0.59. So that is the usual formula for finding probability in a binomial distribution. Remember, NCX, PX, 1 minus P, and minus X. So that's what's going on here. So you actually don't need the table for binomial probability, because you don't need massive calculation to obtain, right? So there are just two probabilities that you need to find, and that can also be easily done by considering this process. Okay, so that's the process, and you should be able to get, if you add these two probabilities together, the result that you will get is around 0.0107, and you can see there is a slight discrepancy between the results, and that is because of the use of decimals in the calculation. That's all. Okay, so don't worry too much about it. Right. Okay, so what I'm trying to say here is, on the third part, you need to find the probability, and you can do that either by referring to the table of binomial probabilities, or you can just obtain and calculate that on your own. Okay, now on the fourth step, you need to start thinking whether you should decide to reject or do not reject the null hypothesis. So the fourth step is making decision, and since we are dealing with this scenario, that means we will be looking at this decision rule. So here we will reject the null hypothesis at level significance level alpha. Our alpha here is 0.05 if the probability here is less than or equal to 0.05 divided by 2. So well, you can see that what we have here is probability k less than or equal to 1, given 10, 0.5 is 0.0108. So clearly 0.0108 is less than or equal to 0.025. So 0.05 over 2 is 0.025. Therefore, your decision will be to reject H0. That's it. And the last part is to come up with a conclusion. So step 5 is to conclude. Therefore, we can conclude, therefore, there is enough evidence to say that the median appearance, basically you are just like copying the last line of the example given. So to say that the median appearance transit time from which its sample was drawn is different from 3.5 seconds. Okay, so that's it. Now there is an alternative approach to step 4 to deciding whether you should reject or do not reject the null hypothesis. Now let's consider some alternative approach. So in step 4, instead of using this rule, you can also consider the p-value approach or the traditional approach. Okay, so if we talk about the p-value approach, remember what you have learned in the parametric procedure. You will reject H0 if p-value is less than or equal to alpha. So in this case, you need to find what is our p-value. So p-value in our case here is the value of probability that you get, okay, 0.0108, and you have to multiply that by 2 because this is a two-sided test. 0.0108 is just referring to one side, and therefore you have to multiply it with 2, and here our p-value is about 0.0216. So compare that value with alpha. In this case, our alpha is 0.05. Therefore, okay, so 0.0216 is less than 0.05. Therefore, you will reject H0. So that is based on the p-value approach. Okay, that's another alternative process that you can consider. Now, another one that I would like to talk about is the traditional approach on step 4. So, okay, I'm just going to erase this part. Okay, so here in traditional approach, in step 4 here, so if you have a traditional approach, remember that the traditional approach requires you to find the critical value, and you will reject H0 if the test statistic that you get, okay, so if test statistic less than or equal to the critical value. So what is the critical value in this scenario here? Now, when you want to find this probability, so this probability of having our random variable less than or equal to KCV, I'm going to call this KCV. So KCV here is the critical value. When sample size is 10, 0.5, the probability of that must be less than or equal to 0.025. So what is 0.025 here? This is clearly from alpha over 2. Okay, so 0.025, and this is the critical value. So we want to find the point where the probability of observing k less than or equal to some value here will be about 0.025 or less. So what we need to do is we need to, again, if you want, you can check the table of binomial probabilities. You go to 10, 0.5, and then well, if you consider this probability, this is too far from 0.025. If you add this probability and this probability, this is about 0.0108. But if you add this probability, then it becomes 0.0547. But this is already exceeding 0.0225. We need to find the point here that gives probability equals to 0.025 or less. Got it? So again, let me just rephrase this again. I'm going to just erase this part. Okay, let me just try to express it one more time. So basically, here is the probability part that you have to consider, but the one that you're looking for is the critical value, which is on this part, the critical value. So what you need to do is you need to find which point over here, when you consider them, will give a total probability of either 0.025 or less. So clearly, if you add up this probability and this probability, you will get a value that is 0.0108, clearly less than or equal to 0.025. If you continue at this one, that will exceed 0.025. It will be about 0.0547. So we can't consider that one. Okay, we need to consider the one that is less than or equal to 0.025. Therefore, in that case, our critical value is this one, this value, because you add 0 and 1 by considering 1 here, probability of 0 and 1, you will get that probability value according to this one here. So when you call less than or equal to 1, that means you're looking for, well, again, probability k equals to 0, 0.5 plus probability k equals to 1, 0.5. So when you add this probability, it will be less than or equal to what we are looking for here, 0.025. So based on that, well, critical value k CV is equal to 1. Our test statistic, which is k is also equal to 1. So clearly, k is definitely less than equal to KCV, right? K is following this rule given here. The result that we have here, k is less than or equal to KCV. Therefore, we can reject H0. Okay, so that's it. And I'll see you in the next video to talk about the idea of large sample approximation. If we have a bigger sample size, then that is a procedure that one can consider. Okay, well, thank you very much for watching, and I'll see you again. Thanks.